Hello, I am Diksha. I am a PhD scholar at IIT Delhi. I will be presenting my work on accurate real-time stereo vision system. Let us first motivate the need for a highly accurate stereo vision system. Consider a self-driving car that needs to navigate through a clear scene. This is an easy situation in itself. Now consider a complicated scenario where these clear scenes are obstructed by inclement weather conditions. In such scenarios, the self-driving vehicle faces certain problems and leads to erroneous results. For example, 1 pixel error in estimating the disparity of an object that is 50 meters away leads to 6.4 meters error in its depth, which takes 320 milliseconds to cover with a car running at an average speed of 70 km per hour. Now, according to half speedometer rule, the safety buffer time is 1.8 seconds. However, due to the error in prediction, the safety buffer time reduces to 1.48 seconds, which can lead to accidents, and hence there is a need for highly accurate stereo vision system, especially for self-driving cars. The next question that arises is whether to go for CNN-based or traditional stereo vision algorithms. Now consider the original Kitty dataset, and we find that for nearly 50% of the frames, the CNN-based stereo algorithm is better than the traditional stereo vision algorithm. Now when we augment the original Kitty dataset with inclement weather scenarios, we find that for 66% of the image frames, the traditional stereo algorithm is better than the CNN-based stereo algorithm, and hence there is no clear winner in terms of accuracy. Now let's understand how did we arrive at the two algorithms that we had been discussing. We performed a characterization of the most popular CNN-based and traditional stereo vision algorithms, and we found that Deep Tuner, PSMNet, GWCNet and HiRIS are the most accurate CNN-based stereo vision algorithms. In comparison, only semi-global algorithm is the traditional stereo vision algorithm that has a comparable accuracy as the CNN-based stereo vision algorithms. We then perform a characterization of CNN-based stereo vision algorithm on CNN accelerators. We use the time loop tool to simulate the CNN accelerators, and we find that a combination of HiRIS algorithm along with the RS data flow architecture is both performance and energy efficient. Thus, the key insight of this work is to use an ensemble-based system and use a predictor to choose between these algorithms at runtime. Upon comparing the accuracy of different ML models, we find that decision tree is the most accurate ML model. We then performed a decision path analysis to analyze which features are being used the maximum number of times in the decision making of a test data point, and we find that brightness and percentage of dark regions have the highest contribution in the decision making of the test data points. This is the hardware design of the predictor. We deploy 4 modules to calculate the brightness and the percentage of dark regions of the two images in the stereo image pair. This is the equation for calculating the brightness. We replace the floating point multiplication with the shift and addition operations. In order to calculate the mean of the pixels, we perform that using an adder tree. To calculate the square, we perform an LUT-based operation. To calculate the percentage of dark regions, we need to perform basically two operations. First is a comparison operation, second is a counting operation. We replace the comparison operation with a simple OR gate, and we replace the counting operation with a binary adder tree. We find that our hybrid stereo vision system is nearly 8% more accurate than a simple monolithic CNN-based stereo vision system. For a self-driving system, we need to be able to quantify the reduction in safety buffer time as a result of the error in prediction. We find that by using a monolithic CNN-based stereo vision system, the reduction in safety buffer time is up to 500 milliseconds, while if we use our ensemble-based stereo vision system, that is PredStereo, the reduction in safety buffer time is only up to 100 milliseconds, and the typical time taken to react and apply brakes is nearly 1.2 to 1.5 seconds. Hence, we get a better safety buffer time with PredStereo as compared to CNN-based system. Thus, the key takeaways of this work are: CNNs are not always highly accurate. Traditional algorithms outperform CNNs for inclement weather scenarios. We can use minimal image features and can predict a suitable algorithm in real time. An ensemble-based stereo vision system is the right choice, especially for safety critical systems. Thank you. For more details, please visit the poster.